In this experiment, I will demonstrate how a chemical compound phenolphthalein is used to determine if a solution is an alkaline or an acid. The first test tube on the left contains phenolphthalein. The second test tube on the left contains sodium hydroxide, which is a strong alkaline. The third test tube contains hydrochloric acid, which is a strong acid. You first pour the sodium hydroxide into a conical flask. You can see that it is a clear, colorless solution. We then pour a little phenolphthalein into the flask. You can see that the solution immediately turns pink. Phenolphthalein turns pink in alkaline solutions. Then we add hydrochloric acid into the flask. You can see the pink solution now becomes colorless again. This is because the solution is no longer alkaline due to the addition of the acid. Phenolphthalein is colorless in acid solutions.
This experiment is a bit like magnetism because there's a negative charge and a positive charge. If a negative charge and a positive charge meet up, they will, the positive charge will follow the negative charge like this. And it will follow your finger. But if two positive charges meet up, they will eventually just fall. They'll just like run away from each other like this. But you can also, but it also sometimes follows your finger. And the negative charges are in your finger, but the positive charges are in these straws here. But you need to like rub them, so that's what makes them do it like this. And then, so you need to rub them.
Go. That's good. Hold it very still.
Hey,
You see that?
Yeah, I see that.
You see that?
is that what happens?
Yes. Ready?
Now, there. This is a Morse code computer program that was written by me and Daddy. This program will display the Morse code dots and dashes for each of the letters in the alphabet and make the correct long and short beeps and light flashes on the breadboard circuit with a beeper and an LED. The code first sets up the GPIO and timer functions in the Raspberry Pi. The code then tells the GPIO to communicate with a circuit board and not display any error warnings. The code then activates the pin GPIO 17 on the Raspberry Pi that is connected to the circuit board. The code now clears the screen and prints the program titles. This is followed by the series of codes for each letter of the alphabet that displays the relevant dots and dashes on the screen for that letter and switches the beeper and LED on or off on the circuit board. Dots will be short 0.2 second beeps and dashes will be long half-second beeps. Finally, the code resets all GPIO pins and tells the user the program has entered. We shall now run the program so you can see it in operation. This is a Raspberry Pi Morse code transmitter program. This program will ask the user to input a message and then transmit that message in Morse code, making the corresponding long and short beeps and light flashes on the breadboard with a beeper and LED that is connected to our Raspberry Pi. We will first define the program functions for producing the beeps and flashes for each letter of the alphabet. This includes the short space between words. The code for these functions was copied from the Morse code tutor program we created earlier this week. The program then sets up GPIO and timer functions in the Raspberry Pi and tells the GPIO to communicate with the circuit board. The code activates the pin GPIO 17 on the Raspberry Pi. The program then clears the screen and prints program titles. Then the code asks the user to input a message to be transmitted. It does not matter if the message is uppercase or in lowercase. The program determines the total number of characters in the message, including the spaces between words. The program now starts the loop, examining each letter of the message, sending the appropriate signal by calling the relevant program function, then going to the next letter. This loop continues until the last letter of the message is reached. The code resets all the GPIO pins and tells the user that the message has been transmitted and ends the program. Let me now demonstrate the program by running it and inputting a message to be transmitted.
Oh, that much.
Okay, we've got just 3 more. Calcium hydroxide.
Hydroxide. Hydroxide. This one? Yeah?
A bit more. It's not much. You should press it, put it down like that, press it in the middle.
That?
Yes. Isn't that a lot simpler? Now, I'll give it a shot. Is it soluble?
Any we haven't done?
Yep.
What about those? The long ones. The long ones not count?
No, long ones don't count.
Oh,
Okay, try this one.
yeah?
Just got 2 more. What are you doing?
Oh wait, this is
A
not.
bit more, a bit more. Okay.
This one?
Yep.
Okay. No.
Is it soluble?
Yep. It's yellow.
What was that? You have written it down.
The nucleus of a iron atom has a charge of +3. The electrons of an atom have a charge of -3. If you add them up, it will equal a charge of 0. If you put iron all in vinegar, you will the atom will gain 1 electron or donate 1 electron. If it donates 1 electron, it will have a charge of 1. If it gains an electron, it will get a charge of -1. Gyroscope spinning. It's like a gyroscope spinning. No, when he takes the photo, that's when you go.
Now, let's see.
The whirlpool is wearing off. World wearing. It's world wearing. Hey, look, is it? way I'm jumping. Oh, ow, oh. This is the best one. Yeah, it's blue. It looks like there's a sponge there. Yeah, it looks like it's carrying a sponge down. Sponge shall go down. We are carrying the sponge. Will the whirlpool have enough power? Please, will it go? The sponge won't go through there, obviously. Go whirlpool, whirly, whirly. Wow. Why is it go ding, 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 ding?
Look at how rapid it is up there.
Oh yeah, it's like
Okay, stop. You just have to do. You don't have to shake the whole bottle.
You only have to shake the top like this. Ah! You only have to shake the top like this. Woo, 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 woo.
Not like this, Rishon. Watch.
Okay, easy.
Just. Yes. Okay, now stop.
Yeah, look.
There, once.
And there. It looks a bit like a jacuzzi. Yeah, but look here.
This is a different kind of whirlpool.
It's like a dusty one.
Yeah, it is.
Whoa, can you see the size of those bubbles? Yeah, because we added soap, there's bubbles.
Okay.
He's like something. Look at him.
It's just spinning.
He must be thinking, my soul's out of control. He must be slicing himself. Now it escaped before it closes. He doesn't know what the word escape means. Spinny, spinny. You must be slicing the whirlpool, but it's not working. Fix, fix, fix. Slice, slice, slice. Now?
Mm-hmm. We poked holes at the side of this bottle,
But,
and if
no,
you,
we poked one hole.
no, we put like 4 holes.
Oh!
Okay, but you can see.
And the lid is a bit like this half because the lid's off, it's red, and the lid's on, it's not.
It is, but the water's not flowing out because there's not enough pressure. There's not enough air pressure.
Yeah, because
Pushing
the
down
air,
on the water.
Because the air pushes it down.
Yes, but because the lid is closed, there's no air pressure, so the water is not being pushed out.
Yeah.
But once you open the lid, the air pressure comes in
And this
and is pushing the water out.
Let me
And you know why? You know why this is called? You know why this is called the booby trap? You know why this is called the booby trap experiment?
So I can put people.
No, because you can just leave it at the table somewhere, and then somebody not knowing that there are holes here will think, "Ooh, I want to have a drink," and then oops. The end.
Wait.
This is us going to make a tiny fountain in a bottle, and it's like this small, and the bottle's this big, and it's going to be used with these 2 cups of water now. It's going to start.
See? Can you see the fountain?
And here's the fountain.
Can you see the fountain? Come closer. Focus focus on the fountain.
Yes, I can see the fountain.
It's a bit like
Whoa!
a worm stuck together.
Whoa!
Wow!
Whoa!
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 Whoa! But it can.
Whoa!
Whoa!
Whoa! Okay,
Okay, it worked for a second. You have to do the U-shaped thing. That's really good. It's about
Rishon, can you close the kitchen door? Oh, never mind.
Ready?
Yeah, so the rocket can blast
It's okay, it's
off.
okay, it's okay.
Wah!
Ah.
Go!
Ah.